Let's look at example 2.7. Example 2.7. If you look at example 2.7, we are asked that is delta star. If you look at it, delta star, that means it is it has no neutral. Automatically, there's no neutral, so very likely you are going to need to use Millman's theorem to solve this problem now as it is. So the question is to calculate the current drawn from the supply. You want to calculate IA, you want to calculate IB, and you want to calculate IC. Those are the current that you want to calculate, IA, IB, IC. So to calculate IA, because this point is S, so you cannot, so this voltage here is VAS. So if I want to calculate IA here, my IA can only be what? BAS divided by ZA. That is it. That is the only way I can calculate this line current. BAS divided by ZA, because this point is S. So that means I need BAS. To get BAS, I need VAN minus VSN. Right. So my VAN I can get from the phasor diagram. My VSN, I have to calculate. What is my VSN going to be? My VSN is going to, I will get it from that, because I'm going to use Millman's theorem. YEAY plus EBYB plus ECYC divided by YA plus YB plus YC. Right. That is what will give my VSN. That will give me this. So, because my EA, if you look at the phasor diagram that is given, because they said EBA is at angle minus 25. So if we put EBA at angle minus 25 degrees, let's look at where our EAB fall. Our EAB, if our EBA is minus 25 degrees, our EAB will be at angle, that is, you subtract this from 180, you get this at 155 degrees. So that is at angle 155 degrees, my EAB. So then now I need to determine the position of other phasors. EAB, what rotation do we have? We have the negative phase rotation. So if this is EAB, right, because it's negative rotation, I will have the next one, I'm going to have EAB, I'm going to have EBC coming here, ECA. Let's look at where our EA will lie. If this is our EAB now, that is, you subtract another 30 degrees, you have your EA here, which is at angle minus 185 degrees. That is 155. It will be at minus 185 degrees. Sorry, minus 185 will be around. This is 180. This is 180 degrees. So minus 185 degrees will come here. So that means it will come to this side. It will come to VA is at angle minus 175 degrees. Because 185 degrees will come to this minus 175 degrees. Then this one, if this is EB, if this is VA, from here to the next phase, it will be 120. So 120 degree from here, it will give you, it will come to, you have to have a VA, VB at angle minus 55 degrees. That's where it will come, right? Then you have another 120, this one from 120, so that can get your VC. So your VC also will be here at angle 65 degrees. Right. So that is your formation. So now when you now want to determine your EA, which is phase, which is at angle what? Minus 175 degrees. So when you substitute, it will be 3. You look at the voltage given. The voltage given in the question, which is the line voltage, is 440. So this will be 440 divided by root 3 to bring it to phase. 440 divided by root 3 at angle minus 175 degrees. So you come to EB. EB is what? It will be 440 divided by root 3 at angle minus 55 degree. Of course, you have to multiply it with the admittance, which is 1 over the impedances that we are given. You can just go through that one to be able to know how to get VSN. You shouldn't have any problem determining your VSN. And once you have determined your VSN, you now, from what I say, VAS is VAN minus VSN, which is this. You put your VSN, you have your VAN from the phasor diagram. Your VAN is at angle minus 175. Therefore, 40 divided by root 3 at minus 175. You subtract your VSN that you get from here, you subtract it from it, you get your VAS. Your VAS, you divide it by ZA, you get your IA, which is this current. And you do the same thing for IB. IB also, IB, which is the current flowing through here, this one is VBS. So IB also will be VBS divided by ZB. So then to get your VBS is equal to VBN minus VSN. Your VSN, you already calculated it. Your VBN, you have it from the phasor diagram. This is your VBN. That's 440 divided by root 3 at angle minus 55. That's your VBN. You subtract your VSN that you get here. You subtract from your VBN, you get your VBS. Your VBS, you divide it by ZB. You get your IB. And you do the same thing to get your IC. You can go through it in your text. If there's any problem, I can also emphasize on it for you. Then the next question says you must calculate the total complex active and reactive power in the load. The total complex active and reactive power in the load, that means the complex power is that means in each of the load, because you have your load SA. Don't forget that your load is, you only converted to delta for the purpose of trying to solve your problem, but your load is in star. Is in star. Don't forget it's in star. But you only converted to delta for the purpose of that is if you are using delta star delta, you only do that to do the bet. Now in this question, you have your load as star as it is. So you want to get the power here, the complex power here, the complex power here, and the complex power here. Right. So the complex power in here is SA asterisk, which is what? VAS. This is VAS, and this is IA. So it will be VAS IA asterisk. That is what will give you your complex power in this phase. And your VAS, you already determined it, and your IA, you have already calculated it. You find the conjugate of it, because it is IAS. You find the conjugate of it, you get your SA. You do the same thing for SB, and you do the same thing for SC. Then from there you add them together. That gives you the total complex power. So from the total complex power, you can split it into the total complex power that you found there was 7.116 at angle 74.55 degrees kVA. So 7.11 cos this will give you the real power, and 7.116 sin this will give you the reactive power, which is what you have there. Then if you want to find what is the cos, the power factor of the because you are asked to find the power factor of the load. Power factor of the load will be cos of this angle that you have in the complex power. The power factor of that angle will give you the power factor of the load. I want you to go through it also. All the ones that I expect you to be doing self-study of most of these things, so that areas where you have problem is what I will focus more. But in the meantime, go through it. If there's any problem, you can let me know on the WhatsApp. Then I will go back into that. Thank you.